Hello, sir. There is no voice. We can't hear you, I think. Hello? Somebody in the class, if possible, to inform professor that we can't hear you.
Correct. Okay. Um, and it's, good morning, everyone. Yes, I think we're at 10 o'clock. We're close to 10 o'clock. And I was writing some ideas here. Let's just back up and go over that. So, here's page one. Let's go. I can't get any closer. Okay. All right. So, there's two SI meetings today. And I don't know for sure, but I'm estimating that somewhere along this week or next week, your SI sessions will be solving problems from past midterms. Yeah, okay. And I had a question further on. See the red ink here? I says, why do you think the administration budgets for 3 SI instructors just for me? Then there's other sections of 240, and they have their SI instructors. You know why? It's hard to get money out of an administration. They don't give up money easily, but they do for SI instructions. If you look at the SI number of SI leaders for all the 121 classes, there's just a small handful, like two or so. When you come to assembly, then there's a whole lot of them. Why do they so readily give up money? Did I? There's one word. Because it's hard. Okay, it's just hard. So this morning, I'm part of a rideshare affair, and so I'm not driving right now, and I'm watching the Reddit subreddit for CSUF. So somebody post this question. It's the best I can remember. It's not an exact quote, but it's best I remember. Who has taken holiday and what does he do online? And this person wanted to know what the class is like. So the responder says, yes, I've taken it, but it's too hard and it's just totally boring. And he says he games during most of the class time. Um, Other students have told me they sleep through class time because of this problem. No, it's not as boring. It's hard. That's what it is. It's just hard stuff. So I was having fun reading about myself on Reddit this morning, and there it is. I told you on the first day of the semester to expect the worst. What can I say to the student posting on Reddit? Yes, it's the worst of the required courses in computer science bachelor's degree program. Administration has seen so many Fs coming through their statistical survey of, of results of classes that they're gladly put up for three instructors. That's very unusual. I haven't counted. I have one friend, Mehdi, who teaches the other sections of 240, and he has his own SI instructors, but the administration, no thanks, and they know rightly this is a hard course. They want to get you through it. So, so they're willing to spend money. They'd rather have a faculty party over in the dorm hall building than spend money for education. So see what was the end of that is I can't make it. I tried to make in the past, I tried to make it fun. There is no fun in assembly. I brought Hershey candy bars and passed them out some days in the past. And I tried famous people just for a change of stress. Nobody like that. And so there's no answer. It's just a hard course. How do you prepare for the midterm? I have some suggestions. For the GDB part of it, make make an ebook of your own. Every time you see me put in a GDB command, record it so that when we get to midterm week, your ebook will have 45 different commands. And hopefully, and very probably, you'll be able to pick an answer out of your ebook. So have them all with you on the test day and use it to get answers. Okay. The suggestion. On the day of the concept midterm, pick one of your past programs. Make assignment 2 or assignment 1 and make it GDB ready and keep it on your computer during the test. You'll most likely have to refer to it right here. Have it ready to run. And when you come to a question that says, show the output of this command, you got your computer right in front of you and you have the program ready to run in GDB mode. You can get an instant answer. Make sure your computer has a screen shooter. You'll copy things and put it into your test on using a screen shooter. And colors, I'm not sure that's really needed, but in your specification for the assignments, I sometimes have a dialogue that's color coded. It says, this is what the user inputs, this is what the machine responds to you, this is what the driver says. Make sure you can show colors. Every year I get not a lot, half a dozen complaints. I can't see your colors in my computer. Well, let's make sure you can see colors this time. If that fails, you can upload it to Google Docs, and Google Docs will show you all the colors. Okay. Let's see. Submissions. Now watch. This is a hard one to understand. I didn't write it down, but let's make it in print. You may submit the test. The test is a document with questions on it and a space after each question to give an answer. Yes. Oh, yes. Test document. in any form, any of these forms. DOC dot DOCX or ODT. Okay. ODT is the open source format that's not owned by any corporate entity. DOC and DOCX are good formats. They came from Microsoft and they're fine, but only. Okay. So when you get the test on the test day, I'll make it in here. And you can save it as one of the others if you want to, but don't save it in any other form. Some students in the past told me, I think you got it wrong, professor. You don't really want a DOC file. You want a JPEG file. So I'm going to make this JPEG file for you and send you that one. Why? I only want 3, and only 3 are allowed. So the next guy comes along and says, I videoed my answer as I wrote it in there. So if you play back this MP3, MP4 file, you'll see that my test answers. No, I don't want a movie. Just one of these 3 and nothing else. Is that hard to understand? Yeah, now watch. The semester will get some oddball formats. I'm just afraid someone's going to send me an audio file because they speak the answers back and send that in. No, that's why I'm making a big deal about this. It has to be one of these 3 only. Okay. Most of you do it right. It's just weird people who think, I don't know what they're thinking. Okay. Any questions about midterm matters? Now's the time to prepare for it. We're going to go to GDB today. That's our main topic, probably our only remaining topic until the midterm comes. So let's pursue it. Agenda is GDB. Let's see, look, I have some ideas of, oh, so GDB is really just a big collection of commands, hundreds of commands. GDB. Okay. And the idea is to get some basic experience so that you can pull out from your collection of commands the one that answers the question. So GDB works on, it's used with all 3 languages that we use in this class. Yes. Used with C and C++ and assembly. You can use it with C++ in isolation without the other 2. You don't have to be paired together. It works on all 3 of them. And a half dozen other languages that I'm not familiar with. Okay. So we want to be able to show, see, when GDB gets a register full of information, it just thinks of it as bits. To GDB, a register is a collection of bits. So it may have a float number, which you as programmer put there as a float number, but it doesn't know that, and it will show it to you as an integer or as binary 1s and 0s. Much of the learning of of GDP is showing it in these different formats. And then, so Richard's bits, but we show it in, show the register in many forms. Okay, so I think I'm going to demonstrate some of the things from last class meeting, but let's let's go on. Okay, okay, let's see if I. So for integers, this will be alive in a moment. Integer m equals 17. Okay. Associated with that is where is m, and what is stored there. Oh, other things. Double cost. What 3.75. Okay. Again, the same questions. Where is that cost actually? And what is stored there? It's not in decimal form of a float number. It's going to be an IEEE number. And arrays uh, such as long my 4 7 minus 3 5 99. Where we're always interested in where is something, where is it, and can I show it in the same numbers in hex? Can I show the same numbers as if they were floats? What does it look like? Does it look like in different forms? How's that? Okay, let's start the live part. I think I still have this program running, and oh yeah, one more attachment here is where and what is activation record. Right. We're going to answer that question too. So let's see, find somewhere in the here in the screen. And, okay, so here's some data. Here's an int. Here's a double. Why is there two doubles? We really don't need that many. 720. I'll leave it for there's a learning experience. You can't express that number exactly, so try to come close to it. There's a long and there's a float, and there's some arrays, and then I don't know if we'll get to the stuff down here. There's some kind of loop going on, but we don't care. Okay, and there's some pointers to be investigated. Okay, so let's keep that in the background. And okay, let's quit. And yes. And run this thing. Okay, it's usually a good idea to check this first block of messages if you have any compiler errors. These are compiler warnings. They're not very important, but it says these things have been declared and you never used them. Why are they here? Even worse, look in this area for line numbers, which would indicate a compiler has found something wrong on a specific line number. Okay, I don't see anything like that. So first thing that we do is make break numbers, break places. Break, I almost always do one at the main and break at line 44. I just made that up. Does that mean anything? Line 44 would be a blank space. Actually, that's okay. It'll default to the next executable line. So it'll break at this one because of my 44. Okay, remember how to run it. Say R for run. The program starts executing and it's ready to execute with a welcome message. So N causes it to execute, gives the welcome message in black font, and then the line 20 is ready to execute. Let's do one more line. And it executed that one, then has line 21 ready to be executed. But let's pause here. What is GDB, excuse me, RBP and RSP are two pointers that mark off an area of the stack that's known as the activation record of the function that's currently running. Currently running is main. So you
Yeah, the
want
sound is really loud.
to investigate those. P/X $sign RBP. RBP is the back pointer. It points to the back end of the activation record, and that's its location. The RSP points to the front end of the activation, and that's its location. And the RSP is always, unless there's a tremendous error, it is always less than the RBP. And if you look at those closely, you should notice that the 3 digits here start with B something something. And the 3 digits here start with F something something. B is much larger than, say it backwards, F is much larger than B, as it should be. Okay. Or I did this last time. Let's do it quickly again. You got to record all this stuff. How to find the number of quad words in an activation record. P/D parentheses R $sign. Can't find it. The big number minus the small number RSP divided by 8 plus 1. Now this is a huge number. 117 quad words is unusually large, but I have an unusually large amount of junk data in that program. All this stuff is being declared here, 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 and here needs not the printf, but it needs space in the activation record to store all that. And the more junk you declare, I have more. There's more, but I don't know why it's so big, but it just is. Okay. So 119. Okay, so for your ebook, put down how you view an activation record. It's x slash 117. Then you put down the format of each of the 117 numbers, which most commonly would be the hex format. In a moment, I'm going to use float format and integer. So let's start with the hex. And the individual number has a size of 64 bits. And so size number comes as the third of three parameters. And then our sign, RSP. It won't even fit on the page. Okay. So as a visual check, this one is BD0. And just higher up, I did, where is it? Here's BD0. It matches. That's the top of the stack. This right now the stack is right side up, by the way. Not the way I drew it in lectures. So this is the stack, right side up, all the way through there. And this one is on the boundary, and this is off by 8. On the boundary and off by 8. So the top one is BD0. This would be BD8. And this is this is BE0. And then this is BE8. Okay. The whole stack's there. And most of what you're looking at is electronic noise. It's not the real numbers from the software yet. They haven't been created. It's paused here. While we're at it, sometimes in 32-bit day era of the past, we always wanted to see 32-bit numbers. And how would we do that? This G gets in the way, and it should be a W. And then here's the stack displayed in as 30-bit, 32-bit chunks. Here's the topmost number of the stack. Does that match? Let's go back. The contents are 088. Here it is. Now, can you figure out what's going on? There's FFF 088 as the content. Here it is FFF E088 here. But what's the rest of the quad word? The rest of the quad word is 000F7FF, which is here. Okay. You notice that they're in backwards order. What's going on? It's the little Indian problem. This number is properly read as the first byte here, and the next byte is here, and the next byte is here. So this one comes first, and then in the listing below, this one will come second, and this will be third. And yeah, we could do it. Over here it is. It's little Indian flipped over. Whoops. That's the first quad word. This is the second quad word of that stack, but now separated as doubles. And for your guidebook, what if you don't like that? You want words. Oh, I did something wrong. Let me bring that back. If it's not W, it's H. Those are technically called words. They're 2 bytes each. It's the same stack, and here it is. But we'd have to read them backwards. We'd have to read these 4 backwards, and that'd be the first quad word, and then these 4 backwards. It'd be the second quad word. That's okay. And I'm digressing, but some people like to work just with bytes. and then it looks like that. This one line is 8 bytes, 8 columns, but every number is flipped over backwards compared to, let's see. See, this one starts with 88 and is followed by 60, by E0, 88, E0. Going to back to, here it is on this side, 88, and then E0 comes next. Okay, I've digressed too much.
Yes, sir.
Yes.
So before we are able to get this list, we have to find the number of quad words, right?
Yes, you do.
Okay.
Otherwise, you'd make a random guess, and yeah, that's true. Okay. Now, this listing is incomplete. When I put in that, see, the 117 says show me 117 numbers, but that's when you're showing quad words. Now I'm showing bytes. It'd have to be 8 times on 117 to get the entire stack. Does that make sense? You could do it, but it doesn't. It's kind of not interesting. What's 8 times that? I'll just go for 900. Okay. And it won't fit on a page, so go through paging. Okay, well, it's a long dump to show 900 bytes. At the top of the stack is BD0. Let's find it. BD0 is given us as the top, and the bottom is F70. F70. Okay. But here it showed up on the first one. It was exact. F70. It's off the page here. There wasn't enough numbers to show it. And so I'll try this very long one. F70. Oh, wow. 900 wasn't enough. It was almost there. It needed a few more bytes to make the complete the activation record. All right, so let's go on. There's that program open. Did I close it? I closed the software. No. No. Where'd it go? Okay, let's open it again. It's down here. Oops. Okay. So part of just the experience is learning what a forensic computer scientist would do. We want to be able to find these items in our output from GDB. The first one coming is the array A5. And let's go back to the screen so you can see it. What's next? A5 is going to be created next. Okay. I wonder if it knows where it's going to put it. So P/X, this is the where question, ampersand A. Okay. It's going to put it at DC20. Is that in the activation record? It is, but you can confirm it. DC20. DC. Not there, not there. DC. Almost. DC20. Okay. And looking at it in bytes doesn't tell us anything. That's a terrible way to view the stack. Let's go back to quad words. DC20. Okay. It has a 1 in the first quad word of the array, but looks like electronic garbage thereafter. Why? Because it hasn't been created, that array. So let's do the next statement. And it says we're going to create M next, but that A array should have been created by now at DC20. And look at the numbers, 2.2, 3.37. Okay. DC20. DC20. Oh, I have to, it's changed. I can't look at the old dump of the stack. I have to do a new one. Okay, so it is X slash, it's gonna be too long. Let's cut it off at 50. And X, and they're quad words, and then it's at dollar sign RSP PC20. Now, you should recognize 400 as a stored exponent. That's got to be this guy right here. And you see 28 is over here. The next number has a 400 stored exponent. And then there's a mantissa. It's probably this one. And we can't recognize any of these, but DC30 has a nice exponent and some mantissa part. It's the array back here. Okay. So if you have an array, you don't want to have to look at the entire activation record. The activation record refers to the area between RSP and RBP, inclusive, including the back end and the front end. Okay, so we should be able to show the array only. X slash 5 numbers in the array. We'll look at them in float form. We'll use, they're each in quad words. I hope that was good. Yeah, see the double here? Those are all quad words. So down here, it will be G space, the starting address of the array. And that looks pretty nice. Even the last one, 6.6, shows up as the last one. Okay. So put it down as an example of showing an array of numbers. Now, we could have said to the poor GB, it's not numbers, it's a bunch of integers. What will it do? It says, okay, here's your integers for the same bits. If you treated them as integers, you get that. And if we, are there any others of interest? None of these are negative. We could have, oh yeah. For some people looking for virus patterns, they look at it as binary. Same 5 numbers, but this is what it looks like. Actually, this is what it looks like to the computer. There's the 5 numbers, 2.2 and 3.37 and so on. Okay, what else are we investigating? After the array comes the number M. Let's get back to what's the next one to execute? I think it just did number M. Okay, so P slash M is a decimal integer, and it's M. Okay. And where is it? P slash X ampersand M. And it says it's there. That's, I guess it still works. I'm not supposed to run things together. There's supposed to be a space in between them. But it still works. And this, see if I can recreate it quickly, slash 50 formatting and X and then G and it's dollar sign RSP. Okay. So the M number says he's at BE8. Did I read that right? BB, BBE. And then 8 means you jump over here. Yeah. Does everyone get this now? We're looking for where did the system store the contents of M? Well, it was declared back here. Here it is. It's a 5 number. And we need to find it in our, the address is BE8. Here is BE0. So it means it's in the next column. But the next column has all this stuff in it. And there's a 5. What's wrong with the representation? The representation is M was declared as an int. And we're looking at quad words. We're not looking at double words. So it's deceptive. That's really it right there. Let's fix that. Look at it as not quad words, but as W. And M is located at BE8. BE0, BE4, BE8. It's right on target. It's where it's supposed to be. And then this would be BEC for 12. It's counting by 4s horizontally. Okay, what's next one we're going to do? Let's skip ahead. Which one would be of interest? More interest are the arrays, but anyways, let's look at float B. Okay, so next, that's an outcome. It's a double. You should all know how to find the words where it is. It'll give us an address that's between RSP and RBP. So P, put it quickly. T dollar signs X ampersand outcome T C O M E and D B F0 D. This is out of date now. The new outcome was created after this was, but we can still see it where after. What is it? It's BF0. BF0. That's the place. And here's where it should be, but it's not 26.5 yet. Let's execute it. And do that same dump just before it, which was X50. X50 is executed. And where are we looking for? BF0. BF0. Okay. I can't read it. It's a small number, 23. Zero. Oh, forget that. That hasn't been created yet. N23 hasn't been created. If we're looking at outcome, outcome is located at BF0. BF0, the outcome is a double. Here's the stored exponent of outcome, and it would read across this way, and then because of little endianness, it has a bunch of trailing zeros. Do you believe it? Okay, so let's change it to what? Here's that number. This is the outcome. It has a nice stored exponent and a very short mantissa. And that goes along with 26 and a half, probably just nicely. Okay, let's say, watch that. What's the next one on our sheet? Let's go for heat. The arrays have always caused myself the most problems. Let's look at what it would look like. We'll do heat and then city and then probably run out of time. Next, and that's okay. And next, and that's okay. And here's heat. Heat hasn't been created yet, but now next again, and heat has been created. So we should be able to find out where it is and what it looks like and how to see an individual value out of this array. We should be able to do all those things. First of all, where is it is P slash X ampersand heat, H E A T, DD90. If life is true, then this is somewhere in the middle of the activation record. You know, and my display up above cuts it short. DD90 is all, it's not there. Let me add this, it needs more space. Let's make it 70. DD90 is here. And right now it says it holds a 4, but I don't think that's right. DD90. No, that is right. We did create heat. 4, 8, 1, -5. 4, 8, 1, -5. You notice negative numbers close to 0 have lots of leading F's, and it all coincides. It all holds together correctly. What? Oh, how do you show the values in heat only without all this in between, all this activation record stuff? So that would be an X slash, heat had 4 numbers, 4. We like decimal, they're integers, and they're all stored in quad words, and ampersand heat. There's 4, 8, 1, and -5. It's okay. And anything else we're supposed to do with heat? I don't think so. Let's go to a string array. Merry Christmas. And where is it? Is it Merry Christmas going to be inside of the activation record? Let's finish this. Okay, next. And it has been created, but now it has been created, and do the usual investigation /X ampersand, ampersand city. That's great. City's name, Merry Christmas. Okay, I won't take the time. DF30's got to be in there. In fact, it's off the scale. Yeah, it's further down. Let's back it up to require, let's go for 100, I guess. 100. So city is going to be stored at DF30. DF, it's still off the scale. Well, we got the DE. It's even beyond that. Okay, we'll try one more time. 120. DF, what was the number? DF30. DF30 is here. Yeah. Now, Merry Christmas is in ASCII, but it starts on this side. 4D is uppercase M. D, you have to multiply. What is C, D, 13 times. I can't do it. Let's see, is there a letter in there we can verify? Merry Christmas has a repeated R twice. Okay, so that's the first, second, third, and fourth character. First, second, you see it coming, 72, 72. There's the EE, Merry Christmas. To us, it looks like it's spelled backwards. And maybe it is, but it's little Indian stuff. So that spells out Merry Christmas, and some of it trails over here. And that's going to be the null character at the end of the line. Well, by the clock, we're running out of time. Let's see, what are registers that are of importance to us? I'm going to do XMM registers very soon. That'll be the next class meeting, I think. They have a different set of rules to abide by, but we can essentially see any place. Let's try it. Just suppose you wanted to see someplace in memory 10 numbers in hex, and they're quad words. And they're located at 0x401220. And that's not a 0, but it's almost a 0. So I took a random address out of memory and asked to look at quad words, 10 of them starting at that place. And here they are. That's the first quad word starting at that address. And here it gives us in blue font the matching address. So, and it matches where I requested it. And then the next one would end in 228. That's this one over here. And then adding 8 more, it's 230. That's this one. I don't know what all that means, but that's not important right now. And so there are parts of memory that are locked. They're restricted from programmer access, especially really low numbers. They'll say, let's try one. You can't get there. Below 400. 3. F. Yeah, see, below 400, 000. is totally reserved for the operating system. They don't want you to go in and intentionally crash it. So it's security protection. Now our addresses, here's addresses in the high end of memory. You could still do control, let's take this out. If you, I'll just take this one. Thing. Wait a second. I'm going to grab that whole number, including its prefix, copy it, and paste it here. And it's kind of meaningless right now unless you know what you're looking for. But if you're looking for a virus signature, you'd study that kind of stuff. Looking for the signature among anywhere in memory. I could, let's just alter it to be, what would I do it? Let's do it again. I don't know, put an F here. And 3 more digits, 000. There's reasons, I don't know why, but it's another case that this is reserved by the system to protect something, probably operating system functions are running. When you have a dual core machine, quad core machine, is running 4 processes at the same time. They have their activation records in different areas than ours. I could have stumbled into one of those by accident. Okay. Um, I think we're done with integers and C++, so next we'll try other parts of the CPU, such as XMMs. I think we're done for today. The time is almost 11. Okay, on the test, I'll ask you some few questions like what you've been seeing right now. Get last semester's test and see what kind of questions show up about GDP. Maybe you can already answer them. Okay. Have a great day, everybody. I'll hang around here until almost 12. Oh,